Okay, hi everybody. I'm showing you guys the solutions to the two review packets. So these are the first 6 problems on review number 1. I marked the ones that were calculator active, so you can see that here. Feel free to pause at any time during this video if you want to jot down some answers or need to check your solutions a little bit more carefully. All right, let's go on and look at the rest of the solutions on this particular page. So now we are seeing the solutions to 5. Okay, and here we have the solutions to problems 5 through 9. And the only one of those that would be one that requires a calculator is part C. On 7 and 8, I reviewed in the little bubble there how you can convert fractions with radicals in the denominator into problems that don't have any radicals in the denominator. So you might want to look at that simplifying. These next 3 problems all required you to use a calculator. When you set up and solve a triangle, don't forget to find the other angle. So I also found the measure of angle A, 64 degrees in that particular problem. The minute we go into the coordinate plane, it's going to be really important for you to use or draw diagrams if none are provided. You have to be a little bit careful if one of your coordinates is a square root, like problem number 14, when you go to find the other missing side, in this case the r value. We wouldn't use negative 7 for r because the r value, the distance from the origin to the point, is always a positive number. As I've said in class, it's probably a good idea to memorize the tangent of 30 degrees and 60 degrees. And then just to note, the cotangents of those angles would be the reciprocals. Problem number 18 is a really important problem for you to pay attention to, especially in terms of how I knew to pick quadrant 4. And it was the fact that it says tangent theta is less than 0, which means the tangent ratio is negative, that allowed me to decide to draw my angle and place my point in quadrant number 4. I had to figure out the y value this time instead of the r value, and when we solve the equation we get positive square root of 21 or negative square root of 21 for the value of y. We use the negative value since our point is located in quadrant number 4. We did 19 in class today, so you can see the answer there. Okay, here are the answers to number 20 and number 22. We're skipping 21. On number 26, when you do number 24, when you do a composite trig expression, remember you're going to work from the inside out. So I replaced the sign of pi 6th with 1/2 and then evaluated the arc cosine. Okay, the solutions to 29, 30, and 31 are all pretty straightforward law of sines or law of cosines or area problems. Don't forget you'll have those formulas provided to you. And please make sure you're using your calculator carefully on them. Okay, now we're on the other review paper, so go ahead and grab that. Pause the video if you need to. You can see the answers here. 1 is B, 2 is D, 3 is A, 4 B. Let me move the paper so you can check the bottom part. Most of these problems were pretty straightforward. They are a little bit more difficult on this packet than the other one. Here's the next part of the first page. So a little tricky on number 7. You just have to add those 2 numbers together, which means you're going to have to make 1 be written as 2 divided by 2, and then you can combine them into a single fraction. Number 10, I thought about that problem by thinking about whether or not I could make a right triangle diagram for B, C, and D. And C doesn't work because secant is hypotenuse divided by adjacent, so you can't have the larger number in the bottom and the smaller number in the top for secant. Okay, when you go to sketch the triangle in number 11, don't forget that both the x and the y values need to be negative, and then you have to compare the size of those fractions. Positive 12/5 is the largest, that's why the answer is D. Here's the next page. We skipped a lot on this page, including number 15. Number 16 is another sum and difference formula problem. And I believe we went over 17 in just about all of the classes today. Some good practice working with finding the period when the coefficient of the b value is a fraction. So we have to figure out the maximum and minimum values of the function to find the range, and the maximum is the midline plus 3 and the minimum is the midline minus 3, 3 being the amplitude. That gives us a range of numbers from -2 to 4. You write that range in curly bracket and square brackets. In the next problem, it turns out that if you start at either point A, point B, or point C, all of the equations in number 19 work. And that graph that has the A, B, and C by it goes with number 19, not with number 18. Here are the last 3 problems on this page. Pretty straightforward. You won't have any degrees on your test on the trig function problems, the graphing problems. They'll all be in radians. These next 2 problems are a bit tricky. You can cross off choice C because we didn't learn about the double angle formula for sine. That's the one with the 2 in there. The first problem simplifies pretty easily to cosine, or to sine, excuse me, I have a typo there. That cosine should say sine, right here where the little hand is on the screen. And then over here, this one does simplify to sine. So A and B are both equal to sine of x. And then there was an error on this one. I simplified all of these expressions. A is the only one that's equal to 1, but B and C are neither one of those is equal to the number 1. Okay, we didn't really need to solve number 25. It was side angle side, and we didn't have to solve 26 either because no triangle is possible. The 2 trig equation problems, the answers might be given to you in degrees or in radians. The second one was a little bit more tricky because it required you to factorize. Remember, if you're going to factorize, you always have to make one side equal to 0. Number 29 was kind of a funny problem. I proved that it's only sometimes true by showing that there are 2 different angles, 2 different A and B values, that could have the same cosine, because there's 2 places on the unit circle where you could have the same x coordinate. If you sketch number 30, I think it's pretty obvious that it's not going to make a triangle, because there's no way to have a 65-degree angle with one leg 12 and the other 2. So a lot of calculator work on these problems. On number 34, you could use the inverse trig function to find the value of all of those angles. To find the inverse trig function for cosecant, turn it into a sine equation first. And here are the solutions to number 35 and 36. Again, to find the measure of an angle in a right triangle, you have to use the inverse function. So in case you missed the answers when we were doing 37 and 38 and 39, you can see those there. Those got progressively more complicated. Please make sure you review carefully how to draw angle of depression. You can see that in 37 with the 33 degrees 40 minutes, and in number 39 with the 21-degree angle. We skipped number 40. I didn't originally have that marked off, so please know that you don't need to know about the course of something. Okay, on our last problem, we had to find the measure of an angle, but we had to find the measure of angle B first, so that was a little bit trickier, and it was using the law of sines. 40 5 and 46 were law of sines and then law of cosines. Those were very straightforward problems. On 47 and 48, okay, 47 and 48 were fairly straightforward, but we did have to make sure that we were finding the smallest angle, and that's going to be opposite the smallest side, which is why I made 85 be the side measure that was all by itself when we went to solve for the cosine of theta. The last two problems were probably some of the trickiest. You need to use the law of sines to find one of these measures. I found B. And then you have to use right triangle and the sine ratio to find the height of that balloon. And in the last problem, I actually made a graph to help me solve it. And I saw that the minimum value was 5 and the maximum 19, and the period was 20. Then I could find the amplitude, midline, and B value. Since the graph started at 4, I translated it 4 units. And since it was a downward sine graph, I put a negative in front of the 7. You need to make sure you switch your calculator to radians to evaluate the value of the function when t is 57. When you do that, you should get 17.7. All right, study hard tonight. Good luck, and I hope you do really, really well in your final later this week.